Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the first actual homework lesson for TopTechBoy's Raspberry Pi Pico series. In today's lesson, we're going to be blinking the onboard LED to find out how quickly we can blink it with seeing a blink versus just having a dimly lit LED. So we're going to start by looking at the hardware, and then we're going to run the program, and then we'll take a look at the code. So first I want to take a look at the hardware that I have set up, and I've made a couple of changes since the last time we saw this. I've added some jumpers for the ground wires, and the reason I've done this is in future lessons we're going to be trying to connect sensors and LEDs and things to these boards, and the only way those are going to work is if we have a shared ground between the device and the Pico. So I wanted to make sure that these were jumpered to grounds. And the way I do that is I look at the chart that Sunfounder has given us in our kit, and we can see that coming down this side we have pin 3 as a ground. Coming down this side we have pin 38 as a ground. And so since we're positioned this way where the USB port is facing me, we're going to come 1, 2, 3 on the what would be my right side, and 1, 2, 3 down the left side, and I'm jumpering to the blue rail, which is ground. And I've done that on both the Pico W and the standard Pico. Now let's flip over to the program and let's run our code. And we can see that we're just blinking the onboard LED on and off, on and off. And let's take a look at the code that's doing that. So we've got, to start off with, we import our pin from machine. This is how we get MicroPython talking to the GPIO pins. And then we're going to import time, so we get our delay function. And I'm going to set a variable, since we know we're going to be changing this and testing with it, I'm going to set a variable for what my delay is going to be. And initializing my pin. And now we get into the infinite loop of while true. So we're going to light the light on, and then we're going to take that value that I gave above and we're going to do some math on it. So in the Arduino world, the delay function is in milliseconds. In the Python world, the sleep function is in full seconds. So I want to translate between the two. I would rather set my delay in this. For this example, I'd like to use a millisecond instead of a fraction of a second type value. So I'm taking my sleep delay value and dividing it by 1,000. So basically I'm saying take my value in milliseconds, divide it by 1,000 to convert it to seconds. And then I'm going to export that as a float because inevitably that's going to be some fraction of an integer. There we go. And so I want to make sure I capture all those decimal places. And then I'm going to pass that to the sleep function. So in this case, you saw that we're doing basically 1 second on, 1 second off. Well, that's a 1,000 milliseconds. So what if I drop that down to 100 milliseconds? Do we get a faster blink? And yes, we do. We do get a faster blink. So of course, the homework assignment is how fast can we go and still see that it's blinking as opposed to just being kind of fully lit dim. So let's try 50 millisecond. We still got a pretty good blink with that one. Let's try 30 milliseconds. And yep, still going. What about 20? Can we get down to 20? All right, on camera it's difficult to see the blinks. I see them in person, but on the camera it's difficult. So let's see how low we can go. Let's try 15. And 15, I really can't see it blinking in person or on camera. So I'm going to stop that. Let's try to find an interim number. I'm thinking about 18 is probably about, yep, 18 is about right. So on camera, you probably can't see it blinking here. I'll go to the big screen, see if we can see it blinking. You can see a little variation, but it's not blinking like it is in person. So we're going to go with 18 as our answer for the homework solution. Now we want to go a step further here. I'm going to stop this. And I want to save this program. And the reason I want to save it is because as we build through the homework lessons, I want to be able to look back at previous solutions, and in time, I'm going to be obviously a better Python coder, and I might want to revisit this lesson and make it better. So I'm going to go, and I grabbed the wrong mouse. Let's try this again. So I always create a projects folder. Here's my projects folder with my TopTechBoy Pico. And you can see I've only got 2 files in here. I've got the firmware files for the Pico and the Pico W. Hold on a second. Sorry about that. And now I'm going to save this program into that folder. So I'm going to click on save, and I have an option. Do I want to save it to the computer or to the Pico? Now remember, the Pico has an area of flash that's basically a file system. That's how we copied the MicroPython image over to it. So I can save it in either place. When I'm writing code for my Picos, I always want to save it to my computer first, because I want to have access to the code on my computer. If I want to make changes later, I'd rather make them on my computer or from a version on the computer rather than connecting to the Pico and grabbing it. So this is going to be Pico, and I'm going to do lesson 00. I always do double digit just so that it sorts better. So this is the first. Oops, I made a mistake. It's not lesson 0, this is lesson 1. There we go. So I have lesson 01, and this is program 1. Sometimes I'll do multiple programs in a lesson, so I just want to differentiate that. And so I'm going to go ahead and say OK and save that. And now I'm going to, actually I'm going to make a change to this program. I'm going to set my delay back to 500 so we can see it on camera. And now I'm going to save it to the Pico. And I can give it any file name I want to. However, there's a special file name on the Pico, which is main.py. And the reason, oops, check that. The Pi 400 keyboard isn't my favorite keyboard in the world. It works. So the reason I want to save it as main.py is because there is a special file name that's written into the MicroPython firmware that says when the board gets power, if main.py exists, run that. So I'm going to save it out to the board as main.py. And now what I'm going to do is I'm going to close out Thonny. So there's no development environment running. And I'm going to flip back to this view. And I'm going to unplug my Pico W. And I'm going to plug it back in. And just like that, it's running the code right off of the Pico. I didn't have to download it. I didn't have to do anything. I just applied power and it's running. So that's the power of saving it as main.py. Then we can go even farther. We can untether from the computer completely. So according to our Sunfounder data card here, I'm going to send positive voltage into pin 40, and I'm going to jumper across here on my breadboard. Measure twice, cut once. There we go. And you can see now I'm completely untethered and I'm running my program without the computer attached. So I hope that was helpful getting up and running in our first lesson. Certainly there will be more that we'll be doing along the way, but I do want to thank you for watching. If you like this video, be sure to like, subscribe, and check out Paul McWhorter's TopTechBoy Raspberry Pi Pico class. Simply Brian Enterprises, I'm Brian. Thank you for watching.